F and G. So the first one says add the two functions and evaluate them at 1/2. All right? So you're literally adding the two functions and evaluate them at 1/2. You can just go ahead and get a new function, x squared, 2x and negative x, combine those like terms, right? And then evaluate means to plug it in. 1/2 squared plus 1/2 plus 3. So 1/4 plus 2/4, common denominator, plus what, 12/4 equals 15/4. All right, the next one is multiplication. So they want you to multiply those two functions and evaluate them at 1. So you're going to take 2x. Now, honestly, for this one, I've got to be honest. I would not bother foiling those if it didn't want the new function. I would plug in my 1 right here. Okay, you can foil if you want to. You have more room for error, I think. So I would plug in a 1. So 2 plus 3 there. 1 minus 1 there. I have 5 times 0. 0. I mean, you can foil and plug in a 1, you're going to get 0. Okay? Does that make sense? So unless they ask for the new function and also evaluate, you can evaluate at any point. Like I could have plugged in a 1/2 here and add it to the 1/2 there if I wanted to. Doesn't matter. The next one is division. So they want me to take f and divide it by g, and they want me to evaluate that at 2. So I say 2 plus 3, that's my f, x squared minus x is my g. Even if they could simplify, you don't really have to. Plug in your 2. So we have 7 up here. We have 2 down there when I plug in a 2. All right? And then f of g, 2 ways to do this one. F of g of 5. You can take the g and plug it into the f and get a new function. All right, so g is x squared minus x. You could say 2, instead of x, say x squared minus x plus 3, right? And plug in a 5. Or you can plug the 5 into the g and get an answer and plug that answer into the f. Either way, when you plug it in, you're going to get 43. So if I plug in a 5, 25, times 2 is 50, minus 2 times 5, which is 10, 40, plus 3 is 3. Or if I plug the 5 into the g is x squared minus x, I'm going to get 25 minus, 5 is 20. Plug 20 into f, 2 times 20 is 40, plus 3 is 43. So either way, I'm going to get that guy. An inverse function just literally switches your x and y's. So if this is my original relation, and here's my domain and here's my range. Remember, my domain is my x, my range is my y. The inverse of that relation, you'll notice my new domain looks very similar to my other range. And my new range looks slightly like my other domain. That's literally what happens with an inverse. You just flip-flop them. Switch your x and your y's. Flip your input and output. So like in a word problem, if it's like, I make $5 an hour for my earnings, so my earnings equals $5 per hour. If you did an inverse, you would just flip those and solve. And you would say, well, my earnings divided by 5 equals my hours. Like it's just a different way to say the same thing, okay? And so you basically have these inverse relations, meaning they're not functions because they don't pass the vertical line test. Or you can have inverse functions where, yes, they pass the vertical line test. But you're legitimately just flipping your x's and y's. So if given something like this, find the inverse. Well, if this is my relation, this is my inverse. I just switched my x and y's. When you graph inverses, they actually reflect across the line y equals x, which we've already done that. We've done reflections, right? And so when we did reflections across the y equals x, you switch your x and y, which we did that when we did matrices, right? So they reflect across the line y equals x. So if my original function then was here, when I did the inverse, it just reflects across. And that's what it looks like. And this is why they're not always functions. So if I took a parabola and did it across, then it's not going to pass the vertical line test. So not all of them actually are functions once you do the inverse, but some of them are, some of them aren't. So that's why it's saying relations here. All right. Now, how do I find it? If I'm given a set of points, that's really easy. Just flip-flop the points. We're done. But if I'm given an actual function, what do I need to do to solve it? There's actually steps that you want to do. All right. So the very first step to finding the inverse is you are going to switch your x and your y. Now, I will say, if it is written in function notation, so let's say it looks like this, f of x is your y, right? So you will say, instead of f of x, you're going to write x, and then instead of x, you're going to write y. So if it's in function notation, this guy's not. Make sure you rewrite, and that's your y, okay? What I mean by that is, had they given it to us like this, you want to write it like that before you switch x and y, because you don't actually have a y, all right? But your first step is to switch x and y. So that's what we're going to do. We're going to take this function, y equals x squared plus 3, and we are going to rewrite it, x equals y squared plus 3. You literally just switch your x and y. And then your next step here is to solve for y. All right, so I'm going to solve for y, get y by itself. So I need to move my 3 over, so x minus 3 equals y squared. Now, this does involve a variable. So y is going to equal the positive or negative root of x minus 3. If it involves a variable, you have to consider the positive negative root. If you are doing order of operations, it is primary root. So if it's all numbers, find the primary root. If it's variables involved, positive and negative root, okay? So y equals positive and negative root of x plus 3. The last thing you want to do is you want to change your notation, and they don't actually tell you this here. And I don't know if they tell you this. Okay, so we're going to talk about notation. And I want to tell it to you right now, because we've actually already defined y, so we don't want to redefine it. That's not y. Y is x squared plus 3. We know that from the beginning of this problem. This is the inverse of y. And I want to go ahead and talk about the notations for inverse. There's 2 ways to do it. They note it one way, but when it's written in y form, y to the negative 1 means inverse, okay? It does not mean 1 over y when you're talking about function notation. So typically in function notation is how I'm going to give it to you, because I don't want you to confuse this with your exponential properties, okay? So in function notation, your y would be represented like that at the beginning. So this is how you would have been given this problem, right? And so when you get to the end, you want to rewrite it. Your inverse looks like that. So the inverse of your original function has this little -1 notation above it. The inverse of f is how you're going to read it, okay? It is not always a function. In this case, it's not a function because you have a positive and negative option. So when I plug in an x, I'm going to have 2 y's that can be generated, a positive y and a negative y. So actually, this is not a function that actually comes out of this one, but it is the inverse of my original. All right? So you want to replace your new y with this guy. So your answer would actually look like this. F to the -1 of x, or the inverse of f, is positive and negative square root of x minus 3. So I am going to give you all of your questions like this, and your answers need to look like that. All right? And they don't actually talk about it till the next example, but I want to deal with it here. right, find the domain and range of this original function. All right. Are there limitations on my domain? Are there any x's I cannot put in there? Okay, so let's think about what domain is. Domain is going to represent my values of x's. All right? So we're talking about real numbers, so we want x to be real numbers, right? But what's my limitation here? I do have a limitation on this function. Yeah, if I have something smaller than -1, what's going to happen in my root? It's going to be a negative in the root. And we're talking about real numbers here. We're not in complex numbers at this point. So x has to be greater than or equal to -1. Everybody agree with that? I have a limitation on my y because it is a square root, my y. So my range has a limitation as well. My y is going to be real numbers. But because it equals the square root of something, we know that my y has to be positive, right? So my y has to be at least 0 or bigger. Y is greater than or equal to 0. So I want to establish that up front, because even when I get to my inverse, if it doesn't look like there's limitations, the limitations that were set way up here will follow to my inverse, okay? So you want to establish your domain and range at the beginning so that when you get to the end, you just flip-flop those domains and range and you don't have to think about what your limitations are, okay? So it wants me to find the inverse. So my next step is to find this inverse here, all right? So find the inverse. Well, I'm going to take this original function that they gave me, and I'm actually going to write it a little bit differently. Instead of f of x, I'm going to write it like this, because my step is to switch x and y. So I'm going to take that, and then I am going to switch my x and y. All right, so now I'm going to switch my x and y. So I'm going to say x equals the square root of y plus 1. And of course, we get rid of the root by squaring it. So I have x squared equals y plus 1. And then subtract your 1. X squared equals y. Oh, x squared minus 1. Finish. There we go. X squared minus 1 equals y. All right. Now my last step is to write it in the correct notation. If I'm looking for f of -1, that's how I want to write it. So I want to say f -1 of x equals x squared minus 1. This is my answer. All right. I found the inverse. All right. Now it says find the domain and range of it. Well, I already found the domain and range of my original function. That's up here. So my domain and range of my inverse is literally going to flip-flop. So my domain of this is going to be, again, it's x's. X is an element of the real, but my limitation is now this. X has to be greater than or equal to 0. My range, which is my output, all right, but now this is my limitation on my y's. Your domain and range literally flip-flop. They change places, okay? So now my domain is that it has to be greater than or equal to 0, and my range has to be that it's greater than or equal to -1. And then they want to know, is my inverse a function? Is this a function? Yes or no? Is it a one-to-one relationship between x to y? So if I put in an x, can I get more than one y? How? Give me an example.
Isn't it square root, so then you have a positive end?
No, the function equals x squared minus 1. And my original was not positive negative root. Was it? What type of function is x squared minus 1? That should look very familiar. You should be able to graph that thing. We've graphed them about 100 times this year. What is it? It's a parabola. A parabola that starts down here. It's actually a standard parabola. That guy's a function, for sure. X squared minus 1. It's a standard parabola that just shifts down. Why is it a one-to-one relationship? Well, if I put in a positive one for x, it's going to give me only one answer, right? So there are no multiple answers here. This is a one-to-one relationship. The original was as well, because the original, you can't, only when you're solving do you take the positive and negative root. When it gives you what it is, you don't take the positive and negative root. It's just telling you the root, right? Only when you're solving. X squared equals a number, then taking the square, you have to consider the positive and negative root when you're solving. But when it's handed to you, you don't. You don't just say, oh, positive and negative root, okay? So yeah, they're actually both functions. Both of these are functions. The original was a function. The inverse is also a function here. Which is what we really just did. If you have inverses of each other, which is what they're saying we have, If f and f negative 1 are inverses, then when you take the composite, you just get x, or you get whatever. In this case, they gave us a number in place of x. So let's say I went back to my ones we just did. Before we do this example, I want to go back to the ones that we just did. So the example that we just did, my original function was this, 10 minus 3x. My inverse function was this, negative x plus 10 over 3, right? Those are my two. What this is telling me is if I take the composite of those in any direction, remember composite's not commutative. It matters, order matters. But with inverses, no matter the order, if I do inverse composite with its function, then I will get x every time, all the time, okay? Just like when I said the composite of the function and the inverse of 2 ended up being 2. The composite of the inverse and the function of 3 was 3, because that was my x, okay? So if I do this composite, f of its inverse, then I'm saying take the inverse and plug it in. So I'm going to say 10 minus 3. Instead of 3, I'm going to substitute in this guy, right? 10 minus 3x. So I'm going to say negative x plus 10 over 3, right? Plug it in. Then simplify. 10. We have, these 3's will cancel, right? Everybody see that? So I have negative x plus 10. Let's distribute that negative through. So distribute that negative through. We have 10 plus x minus 10. What happens to my 10s? Cancel, I get just x. Every time. If I do it the other way, it will also be true. Also be true. So if I take it and I do it the other way, instead of f of the inverse, I'm going to say the inverse of the original function. So I'm going to take my inverse, which was negative x plus 10 over 3, and I'm going to plug in my f. So negative, instead of x, I'm going to write 10 minus 3x plus 10 divided by 3. Distribute your negative. So I get a negative 10 plus a 3x plus a 10 over 3. What happens to my 10s?
Cancel.
They cancel. I have 3x over 3. What can I do?
Cancel 3.
Reduce. I get x.
So
If they are inverses of each other, the composite will always be x. Okay?
You ask me for it. Well,
So if I say, so really what I do is I say find the inverse, okay? You find the inverse. Then I give you two functions and I say mathematically tell me whether these are functions, are inverses or not. Why or why not, okay? So do the process, then tell me are they inverses and explain why they are or are not inverses. And so you're going to do the composite, you're going to get x, they're inverses. Get something other than x, not inverses, okay? It's another way to check as well. If I say, give me the inverse, and you solve and find the inverse, you can check it by taking the composite. If the composite of the two that you found is x, you did it correctly. All right? So composites will always, composites of inverses will always equal x, which is why it gives me these huge numbers, right? Give me the composite of these. I don't even have to do anything. That answer is 374. I have a function and its inverse composite. It's my x. They want that? Okay, easy. My x is my answer. When you have a function, a composite, your x is always going to be your answer. Composite of a function of it and its inverse. All right? You don't even have to do the process.